Hi guys, welcome to Kinemarc. So in this episode, we are going to explore how we can use our calculator to solve any kind of question in the linear algebra math 151 examination. Okay, so for the start, we are going to explore the parts and modes of our calculator. This part displays the mode that you are currently in. So as you can see, CMPLX stands for complex. So we are currently in complex mode. To switch to the various modes, you can use the mode button. So you click mode, and then this is for our normal computations. So you press 1 for the normal computations, 2 for complex, 3 for statistics, 4 for base numbers, say base 2, base 8, base 10, equation solver, matrices, tables, and vectors. For the Math 151 examination, we are going to use a lot mode 1, mode 2, and maybe mode 5, and then matrices, mode 6, and mode 8 for vectors. Let's explore the complex mode. So we press 2 for complex, 2. Now we're in the complex mode. In the complex mode, you have the chance to enter complex numbers. So on top of the E and G button, you can see a small I. So that is for our complex number I. So for a complex number, say 4i, we can just press 4 and then I. So enter, we have in our memory space 4i. Now to enter in polar, in rectangular mode, of course, same thing, 4 plus 3i. And then you have your complex number. Okay, so now we are just exploring the modes. Let's go back to our computation mode. So 1. In the computation mode, you do not have the chance to enter complex numbers. So, and unfortunately, if you're in the computation mode and you've entered a lot and you realize you couldn't enter a complex number, switching to the complex mode will make you lose all that you've entered in your workspace. So always check that complex is on the status bar up there to ensure that you don't waste your time. So we switch to complex mode again. All right, so moving on, we're going to explore complex numbers and how we can perform various operations on complex numbers using our calculator. You note that in complex mode, operations specific to the complex mode are found on this button. As you can see on top of the number 2 button, you have complex written there. Just like on top of the other buttons, you have matrices on 4, vectors on 5, statistics on 1, and then the base numbers on 3. So to access the further complex modes, we will use 2. And because it's in yellow, we can access all the yellow functions using the shift. For the red functions like A, B, C, X, Y, M, we can access them using alpha, including the equal to here. We use alpha to access them. But for the yellows, we use shift. So to access the complex mode, we press shift and then 2. So for the complex functions, 1 is to find the argument, 2 conjugate, 3 is for converting whatever you have into polar or Euler in some sense, and then 4 to convert whatever complex number you have to rectangular. So now we want to find the complex conjugate of a complex number. So by pressing 2, you can see that it says conjugate and then bracket open, meaning conjugate is a function. We need to input our complex number in this bracket, and then the answer is going to be the conjugate of our complex number. So we will do that again, and avoid, in the exam, avoid using the on button, because when you press on, you lose whatever you were working on. But when you press AC instead, you can quickly go back to it. They are still stored in memory. You can quickly go back to the things we were working on and then use left or right to continue editing. So in the exam, so that you can quickly go back to your previous workings, use AC and not on. So now we want to go back to finding the conjugate of a complex number. So I press 2 to access conjugate, and then I enter any complex number. So 4 plus 3i, bracket close, enter. And then I have the conjugate of 4 plus 3i, which we all know to be 4 minus 3i. Awesome. So we know we entered this complex number in the rectangular form. We will explore how we can do our workings in the polar form or the Euler form. Now let's move on to converting between polar and rectangular forms. So same on the complex menu. So shift 2. We can see that there's 3 and 4. 3 has an arrow to r angle theta, and then 4 has an arrow to a plus bi. So 4 is converted to rectangular and 3 is converted to polar. So for any complex number we have, we still use our 4 plus 3i. We can simply go to shift. Unlike for 1 and 2, which are functions, so we need to press conjugate first if we were to find the conjugate of a number, we'll have to press the conjugate first and then enter the number here. But for 3 and 4, you rather enter the complex number first and then you use options 3 and 4. So to convert our rectangular to polar, we've already entered our rectangular number, so we press 3 to access the polar. And as you can see, there's 4 plus 3i convert to r angle theta, and we are going to have our final answer as 5 angle 36.8. Now, what's the unit? Because look at our status bar over here, we have D here, meaning we are working in degrees. So all our angles, all the angles in our final answers are going to be in degrees. And the calculator also expects that in degrees, we enter all our angles in degrees. So if your calculator's mode is in degrees and you entered your angle in radians, your final answers are going to be in degrees, but the calculator also will take the angles you entered in radians to have been degrees. So if you enter 2 pi, it will take 2 pi as an angle in degrees and not as an angle in radians. So you always ensure that the status bar is showing the angle you want to work in. All right, so we have a 4 plus 3i rectangular converted to 5 angle 36.9 degrees. Awesome. Now to convert back to rectangular, we can either just simply press shift 2 and choose the rectangular option, which is 4, and it will take the answer we had in memory because we had used the enter key, so our answer was saved in memory. So this answer contains the polar version of our 4 plus 3i. So by pressing enter, it will convert it back into rectangular, which is 4 plus 3i. Now we still have our answer. If we press answer and we press enter, we have 4 plus 3i. As long as this 4 plus 3i is in memory or is stored in the variable answer, we can go to our complex mode, press 3, and it will convert to rectangular again for us. Awesome. So as you know already, let me convert this back to polar. As you know already, this r angle theta is a notation for magnitude and then the angle. In the angles unit is of course degrees because our status bar shows D. So if we want to find the magnitude of a complex number, we can simply convert that complex number, if it's in rectangular form, convert it into polar form, and then our r here is simply the magnitude. So for our 4 plus 3i, the magnitude is 5. And the angle of our 4 plus 3i is 36.8 degrees. All right. Now to convert, sometimes you need to quickly convert from radians to degrees and back, depending on the question you have in your Math 151 exam. So as I earlier hinted, this status bar shows the angle you are working in, and the calculator will always present the answer in the angle you are working in. So by having our status bar showing D, all our angles will be in degrees. Now we can use this to convert from radians to degrees and back. So on top of the answer key, you can see DRG. This gives us various units of angles. So we go to shift, because it's in yellow, we can access it using the shift key. So shift answer will show us the DRG. So D was for degrees, R is for radians. So if we press 2, it gives us R, meaning that whatever angle we enter before this is in radians. Although we are working in degrees, we want to tell the calculator that temporarily we are entering an angle which is in radians. So by pressing enter, the calculator will ensure that in degrees, all answers are in degrees. So by entering 45 radians in our workspace and having degrees as our mode, the calculator will convert 45 radians into degrees. So let's try that. Let's take a popular angle, which is pi radians. So by having pi radians and pressing enter, we can see that the calculator converts pi radians into 180 degrees, all because our mode was in degrees. Now we can change our mode using setup. As you can see, setup is in yellow, so we go to shift mode, which is take us to setup. And then in setup, degrees is number 3, radians is number 4. We press 4. So now you can see our status bar has shifted from D to R. If we try pi radians again, we are going to have our final answer to be pi, because this time our status bar is showing radians, so there's no need to convert pi radians to radians. I mean, pi radians in radians is still pi. So if we press enter, we get pi here. If we convert our mode back into degrees, which is number 3, pi radians will again give us 180. Okay, so I hope you get a difference. Now let's try to convert 45 degrees into radians. So you think about it. What do you want your final answer to be in? So 45 degrees, let me quickly write that. 45 degrees, you want to convert this into radians. Now you know that you want your final answer to be in radians and your starting unit is in degrees. So what you do is to put your calculator's mode into the unit you want your final answer to be in. So we want our final answer to be in radians, so we're going to shift our calculator from degrees to radians. So we go to setup and then we press 4 for radians. And then now we have our final answer to always be in radians. So we can enter 45 degrees and to put our final answer in radians. So 45, and then we can access degrees using this function on top of answer. So shift answer, we enter degrees, which is number 1. And then our calculator's mode is in radians. So by pressing enter, our 45 degrees is going to be converted into radians. So enter. Now we have 45 degrees converted to pi on 4 radians. Really cool, really cool. Now let's convert pi on 4 radians back into degrees. So we want our final answer in degrees. So we'll shift our calculator into degrees. So shift setup and then select degrees, which is number 3. And then our final answer is going to be in degrees. So we type pi on 4 radians. So pi is on this button. It's in yellow. So we use shift to access it. So pi on 4, and then we specify our unit is in radians. So DRG, we select 2, so radians, we press enter, and then we have pi on 4 radians converted to 45 degrees. It's really awesome. Our calculator is very powerful. You just need to know how to use it, and Kinemarc is going to teach you just that. Moving on, Euler's notation on your calculator. We've already hinted about this particular mode, shift 2 to access all the various functions and the complex. So this magnitude angle is in some sense also Euler's notation, because we know in Euler's notation we have our magnitude E, I, and then our angle, which is the same as what the calculator gives us, our magnitude and then our angle. So to have to convert 4 plus 3i into Euler, we just convert it into the calculator's notation of Euler, and it's going to give us 5 angle. And what did we get? Let's quickly do that. So 4 plus 3i, and then shift complex number 3, and it gives us magnitude angle in degrees. So 5 angle 36.9. So 5 angle 36.9 degrees. Now what if you want to work in radians? Simple. You just go to setup, radians number 4, and then you perform your calculation again. So enter, and this time you have the magnitude is still 5, but our angle is 0.64 radians. So this is also 5 angle 0.64 radians. Now if you want to have pi showing in there somewhere, because in radians we usually have a certain factor of pi, you can simply divide your 0.64 by pi. So in your calculator, you know your answer is 0.644 radians, 0.644 radians, just divide it by pi. So divided by pi, enter. So our angle 0.644 radians is also 0.205 pi radians. So this is the same as 5 angle 0.205 pi radians. Really simple. Moving on, finding the magnitude and argument. Like I've said earlier, for magnitude and argument, you simply need to convert to Euler's notation. It gives you the magnitude and the argument, so we will just skip over that. Now operations to add, subtract, multiply, or divide various complex numbers, it's really easy. You just use your various operations here. So multiplication, division, addition, and subtraction. So we are going to, let's take two complex numbers. So we have our 4 plus 3i, and then we have negative 7 plus 0.4i. So to add these two complex numbers, we simply enter 4 plus 3i, and always use brackets to separate your complex numbers. You will feel the effect of this, especially with multiplication and division. But I recommend that even with addition and subtraction, always separate your complex numbers using brackets so that you just get used to it. It's a common mistake that we usually make, so just let it be a habit. So 4 plus 3i, bracket close, and then adding, bracket open. Now this is negative. Avoid using this button for negative. This is the button for negative. So negative 7 plus 0.4i, so 0.4i, bracket close. So we add these two, and we have negative 3 plus 17 over 5i. You can of course get the decimal version of this fraction using surd to decimal. So you press this button, you have negative 3 plus 3.4i. Really simple. So for subtraction, we can do the same. Now, because I've not pressed the on button and I only use AC, I can always recall my last calculation using the up arrow. And then I use the left arrow to do edits. So then I can subtract these two complex numbers by just replacing my addition with subtraction. Always use AC in your exam so you can quickly go back to your previous operation. So 4 plus 3i minus negative 7 plus 0.4i. Enter. That gives us 11 plus 2.6i. Now to multiply again, I press left or right to edit. Replace this with my multiplication. And then I get negative 29.2 minus 19.4i. Now, if we had not used brackets, take note of this answer. The multiplication of these two complex numbers gives us negative 29.2. So negative 29.2 minus 19.4i, minus 19.4i. If we had not used our brackets, we would have had the wrong answer. You see? And this is not the answer we expected. This is because, if you remember, BODMAS is going to do 4 plus, and it will multiply 3i by this number because multiplication comes before addition in BODMAS. So it will perform the addition of 4 and the product of these two. But that's not what we want. We want to perform the product of 4 plus 3i and negative 7 plus 0.4i. So we need to put 4 plus 3i in a bracket. So always separate your complex numbers with brackets. It's really important. I cannot stress this too much. So 4 plus 3i times negative 7 plus 0.4i, and we get the answer we expect, negative 29.2 minus 19.4i. Division, same thing for division. If we separate our complex numbers with a division, we are good to go. Of course, is this using the divide symbol is the same as using this fraction button over here. So we delete and we use this fraction. It's the same thing. We're going to get the same answer. Same answer. Negative 0.55 minus 0.46i as our answer for using division. Now, a very bothersome kind of question using the Moivre's theorem on your fx-991ES calculator. It's actually very simple if you understand the Moivre's theorem. So let's do a quick recap of the Moivre's theorem. Right, so the Moivre's theorem is a very important application because it helps us to raise complex numbers to a certain power. But this is where we need to combine both the use of our calculator and our knowledge of the theorems. If you're given 4 plus 3i raised to the power half, or to find the square root of 4 plus 3i, you unfortunately cannot directly solve this in our calculator, as we are going to see. So bracket open, 4 plus 3i raised to the power 0.5 or half. This gives us a math error, AC. So we need to combine our knowledge of the Moivre's theorem with our use of the calculator. Now, You can paraphrase the Moivre's theorem as that if you have a complex number raised to the power n, it is simply that complex number by the argument or the angle multiplied by n. If you look here, you can see that if you have ei theta to the power n, according to the laws of indices, you just bring the n into the bracket. So by bringing it into the bracket, if you separate this from the I, you can see that it is simply your argument multiplying n. So we can say that any complex number raised to the power n is simply that complex number by the argument multiplied by n. But we can extend this. This is for a complex number whose magnitude is 1. If we have a complex number with magnitude r raised to the power n, then by the law of indices, this is also r to the power n, and then ei theta n. So again, we still have theta n, but we have our magnitude raised to the power n. Of course, in the case where it was 1 to the power n is still 1, so we ignore that. So we will simply use our calculator and then convert any complex number that we are given to the polar form. And then if that complex number is raised to the power n, then we just take the magnitude raised to the power n and then the argument multiplied by n. So it's the magnitude raised to the power n and then the argument multiplied by n. That's the trick we are going to use to raise any complex number to the power n using our calculator. So let's get into it. Again, we take our beloved complex number 4 plus 3i. And if we are to raise this to the power half or to find the square root of this complex number, we said we are going to simply take the magnitude to the power n and then the argument, we multiply that by n. In this case, our n is half. And then we use our calculator to do the conversion once more. So we've done that so many times, 4 plus 3i. So 4 plus 3i converts to polar, complex polar, number 3. 5 angle 0.64. Always do this in radians. Always do this in radians. So 5 angle 0.64. So we have the magnitude r to be 5. We have our angle to be 0.64 radians. 0.64 radians. So if we are finding the square root of 4 plus 3i or raising it to the power half, we just have to raise the magnitude to half, meaning square root of 5, and then we multiply the argument by half, meaning 0.64 over 2. So in the end, for the square root of 4 plus 3i, this should be square root of 5 with an angle of 0.64 over 2 should give us 0.32 radians. So we can take this again and convert back to rectangular form if the question demands so. So to convert root 5 angle 0.32 to rectangular form, we ensure that our calculator is in radians. So square root of 5 angle. Now we can find angle here. Angle is on this button. So shift this button, angle 0.32. And then we convert this to rectangular. Okay, by pressing enter, it even gives it to us in rectangular form. So 2.122 angle 2.122 plus 0.703 I plus 0.703 I. So we can confirm this using Microsoft Math. So using Microsoft Math, we find the 4 plus 3i raised to the power 0.5, and we have root 5 angle tan inverse of 3 over 4 over 2. Tan inverse of 3 over 4 over 2 is 0.32. So this confirms what we got. 0.32, angle 0.32, magnitude square root of 5, or in rectangular form, 2.12 plus 0.707i, 2.12 plus 0.703i, yeah, pretty close. Alright, we hope you found this video helpful. We are going to upload further videos on how we can use your calculator to solve any Math 151 question on matrices and vectors. Thanks for watching. Bye.